My name is Paul Fowler. I'm the Executive Director of the Wisconsin Institute for Sustainable Technology. What we do here in this lab we're in right now is compostability testing. So we test a whole range of sustainable packaging materials to make sure that at the end of their life, they will decompose naturally in a compost environment. People are making plastic packages out of so-called bio-based materials that are inherently biodegradable. So we have a whole range of plastic films, bags, things like egg cartons, food service trays, clamshells and so on. And oftentimes those are made of cellulose fibres. Where do those cellulose fibres come from? They come from wood. Those wood fibres make up an important part of packaging materials. And what we do is test those materials to make sure that they decompose naturally in a composting environment. We take a tree, we debark it, process that tree, and it breaks down the components of the tree, so the major part being the so-called cellulose fibres. And those are the parts that go into making paper, into moulded fibre, fibres that are used to make so-called sustainable packaging materials. So there's just become a huge sort of public awareness around the impact that plastic is having on the environment and more recently on our lives, maybe in terms of microplastics. So the work that we're doing is about finding alternate materials, demonstrating that those materials are inherently safe, that they have a different end of life than ending up in the ocean or ending up in landfill. To test a material from start to finish, we have to demonstrate that if you take that material and you introduce it into a composting environment, that it biodegrades, turns to water and carbon dioxide over a period of 6 months. We measure the evolution of carbon dioxide, which happens as microbes and fungi decompose the product, so those packaging materials essentially disappear. Then the final piece is plant growth. We use the compost and we grow plants in it. And that's important just to show that the compost that results has no ill effects on the growth of those plants. Ensuring that there's no heavy metals or regulated metals present within those packaging materials. We demonstrate that there's no PFAS or no fluorine present within those materials. And then we use the equipment as well to evaluate the quality of compost. So we've been working with Menominee Tribal Enterprises, or MTE, for about a decade. So we just see them as our go-to partner when it comes to anything we want to do around forestry and forest products. We're seeing this trend away from plastics and towards paper. The mills that were making paper for magazines have closed. Owners of forests like MTE are looking to different outlets for a product that was once used by those mills. One is development of sustainable packaging. Another is looking at how we can diversify the use of those forests in different directions. Things like biochar. How do we incorporate carbon back into the soil to improve microbial diversity and so on? And biochar is one way of doing that. As an amendment to soil to help improve soil quality, soil health, maybe reduce agricultural inputs. Other opportunities revolve around renewable energy, the use of wood pellets for generating energy, whether it's for heat or power or both. We have a feasibility study which is looking at taking some of those underutilized resources in the Menominee forest and using those, maybe do small-scale electricity or heating plants and that sort of thing, in a sustainably managed way. Biomass boiler system is a system for generating heat or power using sort of low-value elements that are coming out of wood processing, where the only sort of beneficial use would be to burn them, to create that energy and then to generate either steam or electricity or both. And that's key, not burning fossil fuel, not using natural gas or not using coal. But the big difference between burning coal or oil or natural gas is the age of that carbon. The carbon in a tree is as old as the tree. You're just returning carbon that was carbon dioxide in the air that was photosynthesized and brought into the tree, and you're returning that carbon back into the environment. So it's in a circle like that. With coal, you're mining carbon that has been fixed in the earth for millions of years, right? And has been stored there. When you burn that, you're introducing old carbon back into the atmosphere that wasn't in the atmosphere for 60 million years. UW-Stevens Point's College of Natural Resources is the largest natural resource program in the United States. And our program is focused on all aspects of forestry through forest products and so on. Students, I think, get a real opportunity to understand and learn, help maybe change the way that we build or design things too. So I'm biased, but I think it's a great program. There's a career for anyone, from a computer scientist to someone who wants to be out in the woods, to someone who wants to be designing a home. There's something there for everyone. Not just in the lab, they're out in the field, they're learning how to use chainsaws, how to manage trees, manage forests at scale. So get involved in forestry, help protect those forests, help diversify the product range that can come from forests, and you've got a career for life.
And so when we look at things in terms of our forest, our diversity, we look at how our people lived in harmony with the forest. There was always a balance. We never took more than we needed. There was always a giving back of some sort, always keeping that relationship we have with the forest, with the trees, with our environment, and with our clan relatives. Understanding the forest is our life, and our life is the forest.
The following organizations have provided funding for this Into the Outdoors television series.